Hello, hello. And we are back. Hello. Is there anyone out there? Anyone? Anyone? This is my second attempt at a live stream today. Hello. I accidentally made a private live stream earlier. Couldn't figure out why no one could see me. Hello, welcome, welcome. Hello, hello. Kind of a thin crowd this evening. Hey. They're starting to filter in. I didn't want to stream. I didn't want to go against the juggernaut that is Joey Does Tech, so I waited. We do have some PS5 power supplies to fix, though, so I thought I would try to do a live stream. See what we could fix. And so far, we have 6 viewers. Hello, Raj3007. And I can't, how do I pronounce your name? Mirachva, I can't say it, and I'm just going to butcher it. I apologize. So it's probably best. Oh, there's Lester. Hello, hello. I recognize some of these names. This is a I know, a rare live stream for me. Hello. Hi. We do have some PS5 supplies to fix. I guess I should just get right on into it. I was going to see if anybody else would show up. Oh, it's going up. 14 concurrent viewers. But I think I'm set up. I'm still kind of new at this live streaming stuff. Hope everyone can hear me. Hi. Hello. Hello, Christopher. We do have some supplies to fix. I actually have, these are PS5 Slim supplies. And I actually had bought 1 or 2 to fix, to have for spares, and then I found these in the closet. And someone sent me these, and I don't remember who it was. I apologize. I think I worked on a PS5 main board for someone, and they included these supplies in there, and with this note, and I do not remember who it was. Welcome, welcome everyone. I'm sorry for the pop-up nature of my live streams. I never know when I'm going to have a chance to do a live stream, or here lately I haven't had a chance to do much of anything but work. But here we are now. So I thought I would try to work on some PS5 Slim supplies. I haven't really done a lot on the Slims because I didn't have any parts for the Slims. I have quite a few parts for the FRs and the DRs and ERs. I've built up a array of parts for those, but not these Slims. And I think this is 3 Slim supplies. And I don't know who sent these to me. Let's see if we can get into this, shall we? Well, I thought it would just pop right out. Okay. Our first victim of the afternoon or morning. Welcome, one and all. Yeah, we're going to be working on a 400 GR here. And I'm wondering if this is going to be. Oh, somebody's been into this one. That's not good. I see lots of scratches along the edge of it there. Someone's been in here. Maybe this is not a good one to start on. Whatever. I'll start on it. And the screws are missing. That should be a dead giveaway. The screws are missing. Should probably have gotten out my pry tools. One moment. I make a lot of noise digging around in this drawer. These other ones. Let me take a look at these other ones. Have they all been opened up before? Well, the first one I grabbed out of this file had been opened. Hello, Kevin. No screws and pry marks on the edge. Okay. No screws and pry marks on the edge. So I thought I was getting some pristine supplies to work on. Well, welcome, Oscar. I'm glad you got to catch me. Like I said, I apologize for my randomness of my live streams. I just don't know when I'm going to get a chance to. I'm going to pry this open. Let's get started, shall we? And these are they're worse than the other ones, I think, as far as getting them open. And I thought that I had gotten a somewhat decent method down on this one, but there we go. I thought I had a good method. Thought I had something good going there. Okay. Maybe I should have opened them before I started the stream. Make a mental note of that next time. Just have them open. So how many of you are coming over from, just got through watching Joey? Anybody out there? There we go. I wonder if this will be the final version of the PS5 slim power supply, or if they'll, cost reduce it, make it smaller. Well, because you remember, if you those of you who worked on PS4 supplies, there were several versions. There was the fat supplies, and there was 2 or 3 slim versions. I can't believe this thing's being that hard to get into, and it's been opened before. Okay. These things put up a fight. Oh, I see somebody was watching Joey. I caught some of it. All right. I have not plugged this in. I haven't discharged anything, but then again, there should not be any voltage here because these have been laying in my closet for months. But just to prove it, we will put the old capacitor discharge tool on there. If I can unwind it from the other many cables in this drawer. Like I said, there should be nothing at all across here. Yeah, nothing. Very dead. As expected. Okay, I've worked on 2 or 3 of these. I've had one that was liquid damaged. I mean, it had been in water. That one was a mess. And I've worked on one that was roach damaged. And this looks to be identical. I'm just wondering if they're going to come out with another version of these like they have on the other ones. Yeah, Joey loves his pizza, doesn't he? He's got a bit of an obsession. Or he's always stringing when he's hungry or something. I don't know. Okay, I don't see any roach damage on this one. Nothing obvious. Doesn't look like it's been worked on either. Okay, let me just see if we have any shorts, shall we? I don't think it's been worked on. He does like his pizza. And I myself have gotten burned out on pizza because where I work, they serve us pizza. They serve us pizza like a lot, like way too much, and so I'm kind of, burned out. Is our fuse good? Oh, fuse is not good. Well, thank you very much. What about that fusible resistor right there? It is still good. So if our fusible resistor is still good, that points to our MOSFETs probably being still good. Is this just going to be a stupid blown fuse? Let's see. Do we have a short? Like if I go from the negative side of this capacitor to the other side of the fuse, the side that's not open there. No short, so it's not like the diodes have shorted. It's just going to be a blown fuse. If it is, I apologize. We'll move on to another one if it is. So we have 39 people joining us. Welcome. I don't know how long I'll be streaming for. Probably at least a couple of hours, I'm thinking here. I do have several supplies to fix. And what is that? I'm seeing something. Let's go into the microscope just a second. If we could. What is this? What is that? That is a carbon trail left behind from an arc. Was there a roach in here? Maybe a single solitary roach? I don't really see. Usually his legs are left behind. Well, there's something there. What is that? This is nasty. I think that's the remains of an insect. So that's what blew the fuse. We had an arc right there. Now I definitely need to clean up that carbon track because it is conductive. See if we can clean that off of there. Oh, that's pretty deep. I'm going to have to dig that in there a little and scrape that carbon out. Let's see, what would be arc between here? What is this? What is this? Is that the PFC? That's the power factor correction transistor. So we may have cooked our PFC circuit. What did we arc? two. This right here. Jumper. It may be ground, or the common, what you want to call it. That's ground, it says. This is one leg of that, yeah, I think that's the PFC transistor. Where's the diode? Oh, wait, is this the diode? Okay. These are the legs of the PFC diode. And that's the MOSFET right there. So, dig that out. Yeah, that didn't just happen on its own. There was something standing there. Something somewhat conductive. All right. Let's see. Did we lose our... I doubt we lost this diode. This diode was pretty tough. It's fine. About this MOSFET. Oh, okay, the PFC MOSFET. If I can make sure it's in the picture. I apologize. Let me zoom back out. No. That looks strange. Something's not quite right with my microscope view here because it's like zoomed in much tighter than what I'm seeing here. Oh well. So we lost our PFC transistor. Luckily I do have some of those now, but if we lost that transistor, if we shorted to the gate, then did we lose something else also? Did we lose something else also? Welcome. Where have I been? I've been working. Oh, there's Joey. Hey. I'm sorry, I'm so bad at watching chat. I need to probably get a separate monitor where I can watch it like in front of me or something, because it's way off to the right and I'm just not very good at watching it. Hello, hello. I was telling the people earlier I did not want to stream. I did not want to go against the juggernaut that is Joey Does Tech, so I waited till you finished, Joey. No one wants to compete with Joey. I do need to figure out why this is so zoomed in. Anyway, but that is shorted, as you can hear. Very, very shorted. And I'm just wondering, I could take some diode checks around the DAP056, but we know we have a shorted transistor, so I probably need to take that transistor out before I even, bother trying to take any measurements, because we're going to have a short. It's just zoomed in so tight. Anyway, I'm going to remove this little MOSFET. I do have some of these. Like I was saying, I finally did get some parts in for this model. Done quite a bit of work and research on it. I don't have my desoldering gun plugged up right now. Probably should. But yeah, we'll remove this. And if we need to replace that DAP056, we can do that. I think I've got that totally free. Let's check. Yep, that's totally free. Let me see if I can. Oh no, Joey, I'll wait for you. Definitely. Let me switch back to this overhead a second. Yeah, this is mounted on a heat sink. So we're going to have to remove the, desolder the tabs of this heat sink to get this out of here. I probably should have done a video on the liquid damage one I had was kind of interesting. Damaged a lot of capacitors in it, little small capacitors. But I was able to find them. Is that the only one? Nope, over here. So we're going to have to desolder these tabs to get this heat sink loose and unscrew it. I guess I could desolder the diode too. You know, just take the whole thing out as an assembly right there. Why not? Why not? That way we can get this whole thing out. There's the diode and the PFC transistor are mounted on a common heat sink. There we go. Is that everything? There we are. There we are. And I'll switch the microscope so you can see maybe the part number. There we go. There is our. I'm gonna have to try to transfer over these ferrite beads too. 40N 60M2. I did get some of those, and there's the diode. And that diode is rather tough. It does not usually go. Let's just confirm. We know it's dead. If I can get my leads on there. Very, very dead. Very, very dead. Okay. Now, get that loose. Oh, where did I put my screwdriver? And I will add, I need to get these ferrite beads off of here. And I'll add some fresh grease, heat transfer grease. This stuff here. They didn't put a whole lot on there, did they? Just to put a little dab on there. But that's not what killed it. It was the creature crawling across it. Okay, 40N60 M2. Where are you? Actually, I have some here. I bought some more. Yeah, I've got 2 drawers of them because I didn't realize the same transistor was used in some of the, I can't remember if it was the PS4 supplies or PS5, but I had some and then I bought more. Yeah. Oh well, we have plenty. If that's all it got. If that's all it got. Hello? It has been a long time. Yeah, I've been away on a magical journey called work. So, let me get these I need to, yeah, don't let me forget to take those ferrite beads off. I'm sure it would work without it, but probably not quite right. Probably wouldn't be good for its, long-term reliability. I'm sure it's to help reduce some spiking or something, some higher frequency components they don't want. Close enough. I think I got those legs bent about right. Hello. Long time. It is a long time no see, unfortunately. I'm glad so many people were able to come out, and I wanted to announce I was going to be live streaming, but I wasn't sure if something was going to come up, or, hated to commit to it and disappoint anybody. All right, let me get these ferrite beads off here. These are tiny, and they may break. I need to warm up my hot glue gun because I don't really have the stuff they use on here is, I guess, what you'd call like a scholastic. And they do that to keep these little things from vibrating. Well, to keep them in position also, but they would tend to vibrate and make an audible noise if they didn't secure them in some way. There's one. And I could use some silicone caulk or something, but that would take longer to set up. So just try not to break this little bead. Come on. But yeah, I don't know if some of you may have missed the very start of it. I have 3 ADP 400 GR supplies here I'd like to get fixed, and I didn't realize until I took them out of the package, because they were donated to me. I regretfully, I don't remember who donated them to me, but they've all been opened up. So we got that going for us. They've all been previously opened, although this one didn't have any signs of work. Just previous signs of insects. But let's face it, that was a very mild instance of insect. Being in a chassis of something, because they can get nasty. Where's my hot glue gun? There we go. Oops, I'm knocking things over. I tend to put things in a spot where I'll remember it, and then I don't remember it because it's out of sight. While this is warming up, we'll go ahead and put a little of this heat transfer grease on here. Which I don't know if this is good stuff. I've used it on these type of transistors before. I just got it off eBay. Just some generic white heat transfer grease. I'm going to use a little bit more than they did at the factory. They were a little stingy with it. And I'm fighting some issues with OBS. Hello, hello. Long time no see. It is. Yes, yes. I'm ashamed of myself, but we're here now. We're together now. So yeah, OBS has been giving me some issues. So I was playing with some settings in that, and it's better now. So I'll learn a little bit as I go. But I've been trying to set up some scenes. Of course, I've got this grease all over me. Or I could show you, diode readings and stuff like that. Trying to get all creative. Let me see. We'll get there. We'll get there. I really shouldn't get too creative. Let's just do the basics. Oh, I'm out of glue. What a time to run out of glue. I just need a little. So it won't move. Oh, this is a pain. Okay. Always such a mess, this hot glue, but just want to get that where it can't vibrate. I should probably put some more on there. Greetings. Welcome. If some of you have not maybe seen my channel before, I work on, try to repair electronics, usually consoles, game consoles. Here lately, a lot of PS5s. Oh, this is a mess. I think my last stream, there were some people that, I guess, came along and, because I saw a question, what do you work on? Because it had not occurred to me that somebody might just happen along the stream and not realize what I was working on. All right. Now, what are the chances I got those leads bent just right where it will fall back in that hole? Well, not too good, apparently. Oh, there we go. There we are. All right. Maybe a little flux. And a little of these mounting holes also. Hello, Tom. Now, I don't think the hot glue, I don't think will remelt. I don't think the supply does not run that hot. If it gets that hot, there's thermal cutouts that's going to go in. Like there's right here where I'm mounting this is there's a negative temperature coefficient resistor for temperature sensing this area. that will shut down the supply. So no, I don't, yeah, you should not run that hot. Should not run anywhere near that hot. Clean that up a little. And I still don't, I don't want to apply power to it yet. I'd like to do some diode checks because I don't want to kill a, a PFC transistor and waste one if I don't have to. Because if the DAP056 over here, drives the PFC MOSFET, and it drives the MOSFETs that generates the 12 volts eventually. But if that output is blown and it's stuck high or something, it will turn that transistor on wide open, and a lot of current's going to flow for a little while, and then something's going to burn open. A fuse will blow. Well, it may just blow the transistor, and then a fuse will blow. So we'll take a quick check. I think I cleaned that arc spot out pretty good. Let me put up, hello. Let me see, where is it? Okay. Our DAP056, I'll even try to orientate the board where it's the same way as that graphic. How about that? How about that? Except you can't see my meter. I didn't think that out very well, did I? I did not think that out very well. I could add it, I suppose. What would happen? I'm trying to get creative here. This could go horribly wrong. Add. I'm still learning OBS. Still learning. Hey, that might work. That might work. At least now you can see the meter sitting there. All right. Is our DAP056 dead? And where is our... This board is turned a way different than I'm used to it being turned. Where's the capacitor? Oh, there's the capacitor. What I'm looking for is this, here we go. The negative lead of one of these capacitors. That's where I'm going to put my red probe. All right. Now, pin 1 looks good. 2 looks good. 3, yeah, that's a low reading, but that's how it usually runs, about 200.2. That's ground. 5, 6, 7 is no connect. And this is 8, which is that 1.5 or so. This one's also like 1.5, isn't it? 1.1. 10, 11. Is that normal? Yeah, that's normal. 12 is no connect. 13, 14, 15, 16. Okay. Now, which one of these? Those all look normal. I didn't see any shorts, any crazy. Hello. Let's look right quick. Like, here's the data sheet for the TEA 2017, which is what I replaced the DAP 56 with. Which one of these is the PFC? Sense current, drain PFC, gate high side, gate PFC. All right, right in front of me, pin 5. Pin 5. Pin 5. My concern was, all right, if you know if that transistor shorted, you could end up with, you know, up close to 200 volts or so DC or more going back into that gate drive output on pin 5. 1, 2, 3, 4, 5. But it seems to be perfectly healthy. It's definitely not shorted, so I will probably be just rolling the dice and seeing if it works. Where is that capacitor? There's one. There's one and there's one. Okay. Pin 5. We are good. 0.6. Yeah, that should fly. All right. I don't see, I'm looking back in the area of the DAP 0. I mean of the PFC. We cleaned out that area where it arced right there. I got some flux there. Get rid of that. I was just looking to see if it had a burned resistor or something on the gate drive. Yeah, that's going to be the gate right there. That's where that arc occurred. That worries me a little. That worries me a little. Ferrite bead. You got a resistor to ground. I think it's a 10K resistor to ground. You've got this diode and 51 ohm resistor in parallel. And then we make our way back underneath all of this, eventually back to pin 5 of that DAP 056. Way over here. So obviously, again, there's not a whole lot in the way. So our DAP 056 could be damaged. So it doesn't show any damage. All right, let's just see if this thing works, shall we? What could go wrong? Who all's here? We're up to 62 concurrent viewers. It is good to be streaming again. It is good to be streaming again. Get this out of the way. I was trying to get this this little camera over here set up where you could see the dummy load, or DC load, whatever you'd like to call it, when I'm doing these tests. I did put some effort into some planning. Some. Turn that fan off. All right. Let's set this about 5 amps or so. Turn it on. What I really should do, if I was smart, one thing, put this grease up so I stop putting my hand into it. I'd like to check the voltage across this boost capacitor, just to make sure we're not, you know, running away, getting into trouble or anything. So I'm going to go right across one of these large filter caps here. Right there. All right. Are we ready? I've got my load connected. It's set for 5 amps. It is on. I'm going to dial down the AC voltage. Turn that on, and we're going to start easing it up. And I'm going to have my arm right in the way, aren't I? I'm going to start easing it up. Oh. No voltage. Know why? The fuse is still blown. The fuse is still blown. I just knew we had self-healing fuses. Yep, I noticed that voltage was not going up at all as I was increasing the AC input. That's not normal. Let's try this again. If we can't fix this one, we'll send it to Joey, because I hear he's getting into power supplies. He may be focusing more on Xbox supplies, I don't know. But I'm sure he'll be happy to have a supply to work on. All right. This is just an 8 amp fuse. And I have plenty of them for now. I usually don't see blown fuses on these things. What normally happens is that something causes these MOSFETs here that generate the 12 volts, something causes them to, is it those? Yeah, those are the rectifiers. Something causes these to short, and that in turn blows the 0.1 ohm fusistor out here. That's what normally happens, and this fuse just normally survives. Not today, though. That's because the short, though, was before, these. I believe I have to look. See, it was before these transistors. The short was on the PFC side, so that's probably why that. These transistors didn't short. It was the PFC that shorted. All right. Maybe we have a little more activity now with our fuse installed. What are you doing? You're back in the holder. Quit beeping. Get my leads hooked back up. I'm going to back across the those bulk filter capacitors. What are you doing? For some reason, my Hakko iron seems to think that it's not in its holder. But I assure you, it is. All right. Are we ready now? Load's still connected. Yeah, this is dialed all the way down. No metal underneath the supply. That's not a good thing. Where's my AC lead? All right. Can we see everything we need to see? We're watching the PFC voltage here. We'll see the output voltage here and the output current and the input AC voltage here. Now, if I keep my arm out of the way, there we go. Now we're getting some voltage. Should start firing off if it's going to here very soon. I don't think it's going to. Nope. Oh, no, I think we started. Okay. I thought it wasn't going to fire. I was mistaken. Oh, there's 120 volts AC in. 393, not bad. 5 amps of current. 12.095. That's what it's showing for the output. Let's give it a little more current. How about that? I'll bring it up to 6 amps. 7, 8, 9, 10. How much current draw we got going in? I can switch this meter. We are drawing about 1.25 amps on the AC side. We're working. Now I need to give it a more thorough test. What I'll do is, I think I've mentioned before, this is very handy for bringing up the voltage, slowly, and giving you a nice place to monitor it and everything. But it's only capable of 2 amps output, so I can't really fully load test this supply to 31 amps of output. 31 amps at 12 volts is a lot of power, so I'll have to go straight to the outlet. I'll have to bypass this to be able to test it up to 31 amps. Oh, well, thank you. Yep, another one back in action, but it was a simple one. One little power MOSFET, but that did look like, that little arc mark, that looked like a roach had crawled in there, and apparently roaches are quite conductive. But at least you didn't make a mess. I didn't see a mess. Like, where's the case? If there's been roaches in it, usually you see all kinds of nastiness inside the case. So it was just one lone roach on a mission to end someone's gaming. I do wish whoever sent these had given me the screws, though. Not that they're anything special. I'm sure I could come up with something, but they kept them. They kept them to themselves. All right. You can still see. All right, let me move this out of the way. What I'm going to do is unplug this. We're going to plug it straight into the outlet back here at the back of my desk, and we're going to run the current on up. 393. That looks pretty good. All right, I'm going to increase it. Tell you what I am going to do. I've got a little desk fan here. I'm going to have a fan blowing on it. I'm not going to run it very long. Of course, outside the PS5 chassis, there's nothing to move air across it. So, running at full capacity, what it would do, it would just shut down. It would go over temperature. There's two temperature sensors on this board that will shut it down if it thinks it's overheating. All right, let's wind it up. We can turn that off. Let's wind her on up. If that's showing up well enough. Oh, this meter's out of the... I'm still working on this little setup over here. 11 amps, 12, 13, 14, 15, 16, 17, 18, 19, 20 amps. This is still running rock solid. The voltage here, you'll see, will be dropping. It's not that low, I can promise you, though. I can put a meter across it. But we're getting the drop across my leads now. I mean, they're decent-sized leads, but they're not, not intended for 31 amps for a long period of time. They will get slightly warm. That's why also you notice these leads are short. They're intentionally, I made these very short, because why add a bunch of resistance if you don't have to? So there's your lead. There's your sample right across the output. All right. Now I'm going to wind her on up. 21, 22, 3, 4, 5, 6, 7, 8. There's 30 amps. We're still solid, rock solid. 31 amps. That's our maximum current. And she is stable as can be. All right, I'm going to wind that back down. I can tell you in the PS5, it's not going to draw 31 amps. A PS5 might draw like 10 or 15 amps. Maybe. I need to check, but I know it's not going to run anywhere close to 30 amps. So, yeah, what I would normally do when I got through working on one like this, I would let it sit here, probably running it like 5 or 10 amps for a time, and just watch it. Make sure it stays stable. I got some more repairs to do on these things, but we did not replace that DAP 056. I have replaced that chip with a TEA 2016, and it will work, but somewhere up around 23, 24 amps of current draw, it gets unstable. This PFC voltage will start winding around, and you will hear an audible chirp from one of these transformers. So, but then I tried a TEA 2017, and I have them both on hand. You know, these. And she'll go to 31 amps solid, no problem. So yeah, the TEA 2017 AAT is the better choice to replace the DAP 056. Because what the DAP 053 and the 056, they're both these TEA chips, but those chips are programmable, so that's why they have that custom number on them. They've been programmed. Somebody, whoever, Delta, who built these things, probably ordered a few thousands of them with slightly different settings in them. And what we're replacing them with is a chip that has just stock settings. For me, the 2016 works pretty good in a DR, an ER, or even the FR. It does not, work too well in this one though. What's the difference? I don't know. A little different circuitry. But because of that, I have ordered some more 2017s in anticipation of working on more of these. Anybody left yet? Anybody bailed on me? No? No? Okay. Let's unplug this. Let's move on. This is going to be. I can tell it's going to be a good supply. So unplug that, and I will plug that back into my Variac. And you can see why you don't want to handle it right now, because there's still 260 volts across these capacitors. So just don't do it. That hurts. I know. But you can see when I'm handling it, I'm very careful where I put my fingers and stuff. I want to unhook these leads. I'm going to put my finger on top of the plastic on this capacitor, this transformer right here. And I'm going to get my capacitor discharge tool, because I don't want to get bit today. And this just, you can probably read it on the meter. It shows 257 over there, and that'll be pretty close to what this thing shows when it's discharging. All right, now we should be safe to handle. Not that I'm going to be handling it a lot. I'm just going to slip it back in its little chassis. Which is in the floor here. Let's see. And even though it's discharged, I'm still not going to stick my fingers up under there. Why? I can just handle it like this. Because you get in the habit of doing that, you won't get shocked when you forget to discharge the capacitors. So make good choices. All right, I'm just going to set that to the side. Pick up our next victim here. All right, our next victim, which does have some signs of roach activity. Yeah, that looks like roach poop. It's not. At least it's not totally snapped back together. It gives me an easy place to start right there. Yeah, somebody open these up. And I guess that's as far as they went. We'll find out. Maybe this one may have a ton of work in it or something. You know, there could be missing components. And yeah, I am trying to be careful with a metal tool like this, but a plastic tool is not going to do any good with this thing. This thing has some rather serious snaps to it. They are substantial. Nothing alive running out of it yet. Nothing yet. I have had one device here recently that a live cockroach ran out of it as I was opening it. And I was doing like this, trying to... That was unexpected. I mean, 99% of them are dead. It's that 1% though. Oh, come on. It's just this one little corner. Finally. How big of a mess do we have? Okay, I see an arc. I see another little carbon track. Doesn't really look all that bad on the inside of the cases though. Doesn't look that bad. But I do see an arc right in here. I'll get you another, right in this area, which I'm going to discharge it before I start touching it. Right in here, right in the middle. What is in that area? It's going to be in this area. I'm not sure what's in that area. It's not like it's the PFC circuit or anything, but that's where I do see an arc there. So I'm going to say somebody got into the 400 volts. That's really all I see. Let's look under the microscope and I'll show you what I'm talking about. Okay. Where was it? Right in there. So yeah, that didn't just happen on its own. That's another, you can actually see the leg. One brave roach gave his life. What else do we get though? I need to, before I forget about it, I'm going to discharge the capacitors. There's nothing there. Like I said, these things have been lost in my closet for about a year probably. I forgot that I had them. Totally forgot that I even had these. But when I saw them, I immediately thought live stream. People love power supplies. And that was like a week ago when I had that thought. I have not had an opportunity to pursue it until today. So I am repairing power supplies and also doing some laundry, which I need to go check on. Didn't quite blow that track in two, but it tried. That's a pretty healthy track. That's obviously going to be ground, I believe. Let's see, is it? Yeah. There's the negative side of one of those big filter capacitors right there. There, right there. That's it. I've got to work on. I don't know why this is so zoomed in. It's probably something I'm doing wrong. There, there, and there's a jumper there. It looks like there's another jumper. No, I lost track. Oh, it goes up here. Here. That jumper. Yeah. There's how it goes. Goes to there, jumps to there. So that's ground, or the negative side of those filter caps. It is not in two. I can patch on that some, but it's fine. So, did we pop our MOSFETs? What did we get? Fuse. Fuse is good. How about that little fusistor? It is good. Huh. Well, if that's good, then I would think these transistors are probably good, these MOSFETs. Yeah. I'm in continuity mode. They're not shorted. Okay. So why is this? I did not plug this in to see if it would work. I mean, I'm thinking it doesn't work, or it wouldn't have been sent to me. We definitely had an arc. Wonder what that would have. That's ground. Oh no, this was ground. So I'm trying to figure out what the critter. Well, the other side is the 400 volts. It's the positive side of the filter cap. There, it jumpers over. So basically, he shorted right across those filter caps, which should have blown something. Not the PFC again. Let me check that. Where is that PFC? Exactly where I left it on the last board. Should be right over here. Did it short that? No. No. Diode's not shorted. We have nothing shorted. Our output's not shorted, is it? No. Output, that's the 12 volt output. That's fine. Well, then it should work just fine. But I bet it doesn't. All right. Let's just check our DAP 056. I will switch back to that view. Try to anyway. Let's see if I can get back like I was earlier. That worked pretty well. I should have saved that view. Or scene, as it calls it. Okay. Oh, it saved it. Okay. Let me look at chat. Look at the board. Look at the chat. Look back at board. Yeah, I haven't had a video in about a month. That's kind of the way my work schedule is. Very, very busy in the spring. However, when we get over in the summertime, I am normally just off. And I can make lots of videos and content for you. So there's a light at the end of the tunnel. It's just kind of a long tunnel. if that makes sense. Where is that negative side of that capacitor? Again, it's really hard to see from this side of the board. What I usually do is I'll take a black Sharpie or something and put a dot by it so I can find it in a hurry. All right, let's see if our DEP056 is still in the living. Good, 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 ground, good, good. That's no connection. That looks normal. That does not look normal. That's low. So it's not, it's usually 1.15, 1.16. So that's suspicious. Let's keep going though. That looks normal. Is that normal? Yeah, that's normal. No connection there. Oh, okay, that's dead short. Not normal on that one. What is that, 14? Yeah, 15, 16. So 14 is a dead short. What is 14? And what is its purpose? Pin 14. Sense capacitor. Well, it's also one of the programming pins if you have a programmable one. Clock and data. Let me find the right. Here we are. LLC capacitor voltage sense input external connected divider across LLC capacitors. That is, I believe, those 7.5 mega ohm resistors that are in series. Let me go to continuity mode right quick light. I'm thinking, I may be thinking of another circuit. Here, so it's going right there, it's jumping to there. And I'm losing track of it. It's not these. There's some large dividers. Well, I guess I need to switch the view. I apologize. Where was I? I was tracking this pin 14 right here. Where does it go? Capacitor there, the resistor. I see a jumper here, over here, over here, over here, right underneath there. Okay, it's the fifth one from the bottom here. Everybody remember that one? Fifth one from the bottom. And then now it's the fourth one from the bottom. And now I think it's the third one from the bottom. Oh well, that's what continuity mode's for. We'll figure it out when we get down here. Where does it go? It's not there. So I lost it. It's not there. Okay, gonna have to be more careful, aren't we? Gonna have to be a little more careful. Here, here, here. There. Right underneath there, there. I'm gonna have to concentrate. We'll lose it. Third one. Third one from the bottom. Or from the right now. Here, here, here. Huh. I did follow it. That doesn't seem to be connected to it though. So my eyes must be crossing as I'm, yeah, that's not connected. So my eyes are crossing. It's there. It's there. It's there. It's there. Fifth one? I'm losing it somewhere. Underneath that jumper. I keep getting here. Okay. But it doesn't, unless something's open. I think it's the more likely thing is that I'm just not on the right track here. I mean, most likely it's just the DAP056 is bad. I'm just kind of curious where it came from. So we're right here, right? I'll just dig into that trace. Yes. Right? And we're right here. Let's see if I can dig into that trace. Yes. So we are here. We are here. We are here. Is it here where I'm losing track of it? That's it right there. So, okay, it's the fourth one then. Okay, then it's the third one. Let's make sure. Yeah, that's it. So when I get down here, we're still the third one. Third one. Everybody remember the third one. Okay. Where's it going under here? Oh, is it going out? Should be going right there. It is right there. So it's this one, this one, this one, this one. Oh, it's there. Okay, I thought I checked that earlier. I really thought I did. So it's this little divider here. Well, these resistors are going to be good. Take a heck of a lot of current to damage them. Okay. Enough messing around. I think we just damaged our DAP056 took a hit. I'm just going to go on a limb and say it took a hit and it is dead. So we're going to get to replace one. That was low, and then this here is also low. In diode, I'm not in diode mode right now. So that's the 15 ohm resistor. I think we just lost our DAP056. I think that's all we did. Let's pop it off of there. What happened to... Sorry, I'm moving some stuff around here. And these things, of course, are glued down. I'm going to use about 350 C air on this. I don't like to go too hot on these boards. They will popcorn on you. So, you know, try to be kind to them. And out she goes. I'm trying to figure out why this is so zoomed in. Because I'm seeing a, oh, yeah. I'm seeing a wider view. Why is it doing that? This is one of the mysteries of this software I've yet to figure out. Oh, there we go. That's better. It just, well, part of it's going to be because I'm using it under Linux. Just kind of does its own thing sometimes. It just kind of likes to renumber the cameras. You know, they're not in the same place they were the last time I used it. Just little things that makes your life worse. Let's see, I'm going to add a little bit of, I should probably get rid of this lead-free stuff that's on here. Okay. Let me get a hotter iron out. And I'll wick that stuff off. Where are my... I do have some more of these TEA 2017s ordered. Get that out of there. Something like that. See if I can just tack one of these corners. Oh, why'd you have to do that? Slide back over there. And slide that way a little. Thank you. Thank you, thank you. Probably use a little flux on this. There's some already, but more solder. I had a little piece tore off and I have used it up. Come on now. There we are. Yes, this tip is way too big for this, but it's what I have in the handle right now. So yeah, this is what I use for, you know, HDMI port legs and stuff like that. A little too much solder there. All right. Excuse me. How's this one? How's this looking? Give it a quick clean. Maybe hit with a little hot air. See if I can get that flux out from under there. I don't like to leave flux on the board if I can help it. Alrighty. Make sure I did put pin 1 in the right area. You can see the little circle. I did orientate the chip correctly, because it would not be good if I did not. All right. let's just confirm. Let's just confirm that that got rid of that low reading on that pin. I mean, I'm reasonably sure it did, but so we're going back in diode mode. Red probe on that negative terminal of that one of these big filter caps. Yeah, we're good there. We're good there. Good there. Good there. This is the one that read a little bit low right over here. One of them that did. Yeah, that's more like it should be. So that came up, and then it was 14 up there where we had the short. Yeah, 14 right there was the one that was shorted. All right, that looked good. That looked really good. Hello. What degree do I have? I just an associate's degree in electronics. I am just an electronics technician. That's all I am. I guess with about 40 years of experience. Where may I pick the right scene here? Okay. Things are falling. So what do we think? Is it going to work? And all you do is replace the DAP056 and clean up that little carbon track that was there. That's all I've done. So that's the only obvious things. Let me get these leads back connected. Get our load connected. I'm going to start with about 5 amps of load. It's on. Yeah. Let's get set back up. I'll meter right across the output terminals there. Get this meter set up. It's gone to sleep. Try to get all the metal objects away from this board to avoid any silly mistakes. Okay. AC input off of the Variac, which is off. Take a drink. Are we ready? Crank this down. So our AC voltage is all the way down. Try to make sure everybody can see the meters. Hello. And all right, so I'm going to start easing this up, the AC input, and we should see this start climbing. And I think when it gets up to about, I don't know, 100, 120 volts DC, something like it wants to fire, we'll watch it this time and maybe make a note of where it starts. So we're coming up. So I mean our fuse is intact, obviously, our rectifier is working, our filter cap is working, because this is our rectified, AC voltage. Bring it on up, passing 60 volts DC, still not running, that's normal. There is 90 volts DC, still not trying to start. There's 100. Oh, yep, right there. It was somewhere around, well, just below 100 volts AC. You got up enough voltage to actually try to run. And we're running. 396 volts across our filter caps here. 12 volt output. Looks good. I'm going to bring this on up to 120 volts in. We're running. Hello, hello. Are we talking flux again? I'm using, it's Kingbo, and it may be fake Kingbo. I really don't know. It's this stuff I buy in the tubs. You know, it says Tokyo, Japan. It does have the spelling errors on it, though. So is it real? I don't know. I honestly don't. But it does work. It works for me. And I just fill up some syringes. I'll dump it over, which is always a mess when you go to do that. Getting this into this tube is fun. And then getting the air bubbles out of it. But I have, 2 or 3 tubes of it loaded up here. Ready to go. And it lasts me a long time. So is it original? Is it authentic? I have no idea. Probably not. I'm buying it off eBay. But it's inexpensive and it works for me. So I really have no idea. I wish I knew where to get some authentic. But it works for me. I've used Amtech before. It worked for me also. It's a little more expensive. It works. The Kingbo was working for me, so I just, that tub will probably last me a year. So that's why I'm kind of stuck with it. The only downside I can see to it is it does tend to burn. Like if you're soldering something too long, if it's taking you a long time to desolder something, it will start to burn relatively quickly. I'm sure they all will at some point, but maybe the Kingbo is a little faster, or what I'm using, maybe a little quicker to burn. It's not usually a problem though. So we are running. I think we have a working supply. Let me run this current up a little bit higher. 10 amps. We're nice and stable here. We're stable on the output. We're drawing, what are we drawing? About 1.25 amps on the AC input. The voltage you can see if you watch this, the voltage starts dropping. It's not the stiffest supply. You know what I'm saying? You will see, like if I turn off the load here, you'll watch this voltage pop back up over 120 probably. There you go. See, now it's 130. So not the stiffest of supplies, because it's just a small transformer in there with like a continuously variable tap, you might say. But it works for what I'm doing here. But you can see, which is why I say when I'm working on a PS5 and I turn that thing on and I see this dip, it's because of the surge current of the supply coming up. And if I don't see that dip on that meter, I know nothing happened. The supply did not start. So anyway, because it's just, but it's very handy. It looks nice and stable. I guess I should go ahead. Let's give it the full test. We're only drawing 10 amps, but you can see this only supplies 2 amps. It's got a 2 amp slow blow fuse in the output, and we're already about 1.25. So I really hate to push it, and I do have some fuses, but why blow a fuse if you don't have to? So let's turn it off. I'll just plug it straight into the AC outlet, which is just 120 volts here in North America. But if you're in a country that has 240 volt AC, it's the same supply. It's the same supply. It's just that your PFC voltage is the same. It's like 395 or 397, whatever. But like if this PFC doesn't start, what you get is about 170 something volts across these. Because if you rectify 120 volts AC, you get about 170, 180 volts DC. So if your fuse is good and your rectifier is good and your capacitors are good, but the PFC doesn't start, that's the voltage you'll see. Whereas in other countries where it's 240 volts AC, that's probably something more like 340 volts that you would see. So, but anyway, these are universal supplies. These work at anything probably from 100 volts AC up to 250 or something. It's the same supply. It just runs, you know, if you think about it, in a country where it's 240 volts AC, the power factor corrector probably is not working as hard. It's not having to work as hard. There's not as much current draw because you've got a higher input voltage. You don't need as much current to get the same amount of power, if that makes sense. Can you modify a transformer from 120 to work on 240? Some of them have taps, but yeah, that gets to be kind of dangerous. If it's tappable, I mean, some supplies, some transformers have a 240, 120 tap, but not all of them. And of course, these don't. These are not AC sine wave type. These are pulse transformers, so they work totally different. All right, I'm at 10 amps. Shall we wind it up and see how high we can go? 10 amps, 11, 12, 13, 14. Let's just go on over. 20 amps. Still solid and stable here. Output looks solid. It probably dipped a little. Not much, though. You can see it dipping just a little. It's not bad, though. 31 amps. And we are rock solid. And this is where the TEA 2017. 360 watts of power dissipation. All right. And we were putting out just over 12 volts. That's great. Run it back to 10 amps. I don't even have the fan blowing on it right now. All right. We're 2 for 2. 2 for 2. Yes, this is a PS5 Slim power supply. This is an ADP 400GR. And I don't know if you can see. You know. And these supplies, like you can see, can you see the part number? Not really. Trust me, it's an ADP 400GR. It's basically the same supply used in the DR and the ER and the FR, just repackaged to fit in, you know, whatever free space they had left in the Slim. I'm sure they designed the PS5 Slim and then told Delta, hey, all right, make us a power supply. You have this much room to work in. Make us a 360 watt supply that will fit in that space. I don't know if they fail that easily. I think I've mentioned this before, though. I mean, PS5 seem to fail a lot, but then again, I only see failed ones. So, you know what I'm saying? And these PS5 power supplies seem to fail a lot, but then again, I only see failed ones. So my view is a little bit skewed there. I only deal in broken ones, so to me, they're all broken. All right. I think we're done with this one. Let's unplug it. Yeah, this is a, you can see on the board there, this is built by Delta. They make a lot of power supplies. There's Delta, there's also Cherry, there's, I think, Light-On that have made supplies for these consoles over the years. It's probably whoever the lowest bidder is. That's just my theory. You know, when you're making millions of these things, and they have sold millions of PS5s, you know, every penny counts. I mean, they will get the cost down as much as they can. Let's see. All right, we are unplugged. Disconnect my load. Still have 260 volts across our filter caps. Let's bleed that off. All right, we should be nice and safe. But again, I'm still not going to handle the back of this board with my bare hands if I can avoid it, because that's just not a good habit to get into. Slip it back in the chassis. And I pick it up by the wires. It's just a habit. All right. But yeah, these are pretty neat supplies. It's just amazing to me how much current they can get out of these things for such a small package like this. And it doesn't have its own fan or anything. It's relying upon the airflow of the main fan in the PS5 to draw some air through this. To keep it cool. Doesn't have its own cooling. It just gets a little bit of the cooling. Good evening. Yep. This is a PS5. I have one left. One left. And what time is it? I'm not sure how long I've been streaming here. Surely there's a number here somewhere that says. Nope, maybe not. Let's get this one open. This will probably be my last one. I do have a box of other PS5 supplies. This is my last broken slim supply that I have on hand at the moment. But I do have a box that was sent to me of the GRs and the DRs and ERs and whatever. To go through at some point. Okay, so let me get this last one opened up. And this one's going to fight as well. Although it's not totally snapped together. Well, come on. Why do every one of them have to... Okay, finally. They have a lot of snaps. More so than the older ones. Come on. Okay. Guess I need to start from some other side here or something. I'll make sure it didn't have screws in it. I thought they were all missing the screws, but I have done that before. Pride on a power supply. Only to realize it still had the screws in it. I'm trying not to repeat that mistake though. Come on. This one may not want to get fixed. Really? Trying hard not to break the case. Why is this one worse than all the rest of them? Okay. I mean, I've tried it from every angle here. I guess I could just pick another spot, but it usually just makes it worse. And usually, if you get it going somewhere, you know, you go with that. And I don't want to pry in there and damage the circuit board, which is certainly possible to do. I win, I think. This is probably the worst one I've ever seen. They're not glued together. They just have a lot of hidden plastic snaps, like very close together. Like where these slots are, there's definitely, I don't think I can do anything with that. There's definitely a snap right there at each one of these little slots, you can see. But usually they will release. I mean, come on. This is getting exhausting. Now I'm just getting frustrated. This is ridiculous. Why do this? Why do they seal them like this? What do I do with that other? I had another pry tool. Oh, it's over here. Yeah, definitely if I do this again, I think I'm going to have them already opened to to save myself this embarrassment. Although, I guess some of you out there probably would like to see how to open one of these things. Not that I recommend it. Not that I recommend it or anything. So close. So close. It's almost like it's welded there. Like plastic welded, but I know it's not. Wow, now I'm sweating. But it did not defeat me. What do we have here? I don't see any convenient arc marks on this one. So do we have a blown fuse? Fuse is good. Fusible resistor is also good. Has that chip been replaced? I see signs of flux, looks like around the DAP056. Let's look under the microscope. It just looks like the solder looks particularly shiny. Has this been replaced? It has been replaced. Oh, with the DAP053. That's not original. Although I would think a DAP053 would still work. I'm not sure though, I never tried one. Big old glob of solder right there, isn't it? I'm sorry, my nose is... Oh, let's get rid of that. I don't want that floating around. So, they put a DAP053 in here. It is oriented right. I'm guessing it didn't run though when they did it. Any other? Oh, look at there. There's that ground leg on that capacitor. They've been probing the hell out of it. I do that sometimes, but yeah. So somebody's worked on this thing a good bit. Ooh, that doesn't look right. That doesn't look right there, does it? R7 has seen better days. Now is this, yeah, that's going to be the drive to the PFC, I believe. Yeah, there's your PFC MOSFET right there. There's the gate. There's the diode. So this is in the drive circuit for that PFC MOSFET. You can see the remnants of a roach as well. So it's probably a hint as to the history. So is that MOSFET good? Are you a good MOSFET or are you a bad MOSFET? I'm in continuity mode. Doesn't seem to be shorted. The ferrite bead is not open. I'm reading 1 ohm across this. which is a diode and resistor in parallel, reading 1.24 ohms. So that, I'm going to say that diode right there is no longer with us. No longer with us. Yeah, I get 1 ohm either direction, so I'm going to say that diode is gone. Resistor is probably okay. Of course, that is then, we followed that earlier, that is driven by this DAP056 over here. So what else is wrong with this? We go to diode mode. Look at some of these Zeners around here. That looks fine. There are a number of them. That looks fine. How about this one right here? That's probably fine. There's a pair right here. Actually, yeah, these are both Zeners. I thought one of them was a regular diode, but it's not. That looks fine. So, what about our DMP014? That has not been changed. It looks to be factory fresh. This is a Zener, a 9.1 volt Zener. I think it's 9.1. It looks fine. It's not shorted anyway. How about right here? Oh, well, I think my leads are touching. That's all it is. Yeah, that's fine. I was shorting against something. So, are some of these leads not soldered? They probably are. So I probably need to go ahead and change that back out. And I need to see what this resistor is right here, which I think it's usually like a 10K to ground. Let me check. Let me check some notes. Because I cannot remember. That was R7. R7 does not look very good. R7. R7. What is R7? It looks like it's on the gate of that PFC. That is a 10K ohm, which may still be good, but it doesn't look very good, does it? I mean, I wouldn't trust it. Yeah, it measures 122K ohms. So that needs to go, and that needs, this A6 diode right here measures, yeah, 1.2 ohms. All right, let's get those swapped out. Anybody still watching? Hello. Pushel, I've seen you around on many channels. So we need a 10K ohm surface mount resistor. What size would you call that? About a 0805 maybe? Oh, and I just dumped a bunch of resistors on the ground. Yeah. Yeah, a whole bag of them. That's great. That's great. Yeah, somewhere in here. Somewhere in here is the resistor I need. Somewhere. I think if this is the right size. Let me switch. Let me look and compare. This is a bag of 0805. So no, Going to be the smaller ones, isn't it? What's the size down from the 0805? It's definitely not 0402. 0603. 0603. That means I get to sort through this pile of resistors later on, because I do have a book. $10K. Wouldn't be surprised if that's 12K. Sorry. Looks like I have used a few of these. Very popular one. See if I can put it somewhere where I don't lose it. I'm going to put it off to the side. If I set it on that board, I'm going to blow it off whenever I use hot air to remove the old one. And I also need to locate a diode. A6 diode. Do I have an A6 diode? What is an A6 diode? Is that a BAS 316? Because I have that right here. Yeah, I got it written there. A6. Okay. Usually I put it on the label. I need to do it. You know, I'll put BAS 316 in the parentheses. I'll put A6. So when I'm looking, I can find it. All right, let's see if we can get these changed, shall we? But we're going to be very lucky if that's the only problems, I'm afraid. Very lucky. Although I said the PFC transistor did not seem to be shorted. Oh, got an alarm. Get rid of that. Now, where's my good one? And my diode. Let's see. Oh, come on. Cooperate. All right, fine. Oh, and then it left. And then it left. That's what happens anytime you try to do some last minute straightening, you know. Let me put some Leaded solder on that. There we are. All right. Maybe I haven't made too much of a mess. Wash the markings right off that transistor. I mean, not that resistor. .8 k ohms. And this should be 51 now. Yeah, it raises 50 ohms. So that diode is no longer shorting around it. So make sure this 0 ohm is good. It does look good. What else? See, there's one of your temperature sensors right there, mounted behind the PFC circuit, behind the PFC MOSFET and the diode. There's another one near the other MOSFETs that can also make it shut down. I have seen one time one shutting down, not one, it was an old PS4 supply. Kept shutting down, I couldn't figure out why, and one of these, it had a crack in it. It had a hairline crack right at the end cap. Very strange. All right, I really want to go ahead and change out this DAP053 that they put in here for a 5.6. Or a TEA 2017. Oh, thank you. My live stream, you know, people seem to be enthusiastic about it. I mean, I've been looking forward to doing it. You know, overcoming some technical issues. Oh, this is that really zoomed in. Let me fix that. Yeah, that's how it should look. Dadgummit. Didn't know it was doing that. Sometimes these scenes just seem to change on their own sometimes. I didn't have it zoomed in like that, but it was zoomed in. And I do apologize for that. Got to go through and check all these scenes and make sure it's not doing any weirdness. And I've got to leave here in a minute to go get a haircut. Important stuff. Oh, come on. That's what you get for rushing. Now, sit. And nice short right there. It is a nice bridge. Maybe that'll flow out when I heat this up. No, it's the same pin anyway, it doesn't matter. Up here. Thought there was a bridge, but that's just pin 1 to these. They always have these big test pads right by pin 1 and 16 for some reason. I just want you to sit. Something like that. Stay there. And then jump like you're an Olympic athlete. There you go. Come on. All right. Stay there. Almost. Almost. Okay. Now I'll touch those up. And we'll be ready to test this one, I believe. I should probably change this tip, but it's like, at least there's plenty of room around this chip to do this with. I mean, it's not like I'm melting any plastic adjacent, because there isn't any. All right. Let's see, we didn't have any blown fuses or blown fusible resistors on this one. That I recall. All right, so we've got a fresh TEA 2017. We'll just give it a try. What could go wrong? I did orient it the right way. Yes, I did. All right. Okay. That's not what I wanted. Okay. That's still not what I wanted. All right. Let's get some leads connected. Get the load connected. Observing the proper polarity. AC in off of the variac. Turn it all the way down. Connect it. All right, so we are metering. I should probably meter the output voltage over here. If I can get in these terminals. Okay. DC load is connected. It is on, set for, I'll bring it down. Let's say 5 amps. That's a good starting point. It's on. Here's our PFC voltage. Make sure you can try to get that glare off of there. All right. I'm going to turn it on the AC voltage, start bringing it up slowly. And move my arm out of the way. Try to get it where I can actually see it too. All right, we're coming up. We're at about 50 volts AC, 60 volts AC, 80 volts DC. Come on up. Should be getting close to trying to start. No, we're not starting. We are not starting. Darn. I'm going to have to leave here in a minute. Our PFC did not start. I don't think it even, no, it never even tried to run the 12 volt output. The PFC never tried to run. Okay. Why is that? Of course, we know we had some damage in the PFC circuit. So apparently we have not found it all. I'm going to discharge these capacitors. Okay, we're down to 3 volts or so. Safe enough to handle. So what am I overlooking? What am I overlooking? Is there? We know it's been worked on around this area where the DAP56 is. Anything knocked off? Anything missing? It's always a good idea to look where there's been work before. Of course, we could have a dead DMP014. But I don't think so, though. I say that because it's not like this is a, I don't think this is lighting. This is bug damage. And it was bug damage on the hot side of the supply, on this side of the supply. And the DMP014 is on the cold side. Pretty well isolated. So most likely we just have a problem over here on this hot side. Something, maybe a shutdown transistor, like Q33 down in here. I did not check. Well, we're not running though. We're not running. Back under the microscope. Back under the microscope. Did I put the A6 diode in? Well, look, we will definitely check. I believe I did, though. I believe I did. We'll find out, though. Let's look back in that area. Now, is that right? It has a line on the board, which I thought, we'll double check another one. I think that the line is the cathode. See the line right here on that silk screening? So let's look at another one. I mean, and where the band is on this A6 diode is definitely, that's the cathode. So let's look at another one. Another diode. Just find any other diode. Yeah, look at this one. See the banding and the line on the silk screen? So, and we can even look at one, there's another A6 diode. Where did I just see that? Right there. There's another diode like that. See the line and the band and the marking on the board. So yeah, I believe we're right on the orientation of that A6. The ferrite bead did not seem to be open. The resistor did not seem to be open. It wasn't open. The MOSFET was not shorted, and they don't usually go open. Not usually. They generally fell short. So, yeah, that ferrite bead is good. And yeah, this resistor had like 9.8K or something in circuit. Yeah, 9.5K ohms. I think that's fine. Is there something else around the DAP? .056. Like, do we have, I mean, there's a lot of things. Yeah. I can lift the shutdown opto isolator and see if that would let it run, but I did put this chip in properly, didn't I? I believe I did. Let me check this Zener right here. That would mark ZD. Yeah, that 0.58, that looks fine. I know this is the circuit that's monitoring the output of the PFC. Monitors at 395 volts. it's divided through some resistors, and there's a zener to limit it, and it goes in here on pin 2. And there has been, well, I may have put that solder on there. So what? A lot of probing going on. Looking at that terminals. A lot of flux left on the board, and that's by me. I haven't cleaned all that up yet. So she doesn't, it looks like it doesn't even try to start. It's not like it starts and shuts down, right? Although it could be doing it so quick I don't notice it. But it acts like it's, maybe I need to meter to see if the voltage is making it. This chip is powered, you know, when everything's up and running, it's powered by this circuit here. You've got a winding on the primary side, and it comes from right there. Ferrite bead is a diode, and there's a little circuit here that regulates it. You get about 17 volts out of this circuit that ends up on whichever one of the VCC is. I think it may be that one with that big filter cap right beside it. That's what starts it. That's what it runs it once it's you know, once it starts up and running. But the initial voltage to get it started is supplied from the raw DC. It has to basically supply its own startup current. And once it does that, it should try to kick over. And I'm trying to remember which one of these pins that comes in on the original startup current. Oh, hello, David. Thank you. Hello. So which pin is that? I'm trying to remember where's that data sheet? Where's that data sheet? Yeah. Oh, why did I do that? Why did I do that? Anyway, so which one of these is responsible for pin 13? Input supply and output of internal high voltage startup source. Externally connected to an auxiliary winding of the LLC via a diode or to an external DC supply. So that's the supply in. Internal startup source. But the initial, here we go. Internal HV, pin 8, internal high voltage startup source, also used for X capacitor discharge, valley detection, PFC or voltage protection, connected to PFC drain voltage. Is that getting there? Is that making it pin 8? So that should hook to the drain of the PFC, which basically means it's going to be getting raw 180 volts or something right now. So if I go to continuity mode, pin 8, right? Where is pin 8? Is it that one? Oh, that's the one through a 15 ohm resistor, isn't it? So where does that go? Right here, right? And there, yeah, that's not the right one. What am I following? I'm off. I forgot this is a 16-pin chip. That's what I did. I'm on pin 9. That didn't make sense. I went to the 12-volt MOSFETs. That didn't make sense. I'm looking for something connected to the PFC MOSFET. So pin 8 would be over here because it has 16 pins and not 14 pins. Where does that go? Underneath these rather large resistors. These two 2,000 ohm resistors. Ooh. They are open. I think. No, they're not open. I think I'm in continuity mode. Give me a second. I'm in continuity mode. They don't look burned. Yeah, I'm measuring about 1K ohms. Two 2000K ohm two 2000 ohm resistors in parallel, so you get about 1K ohm. They're not open. I was mistaken. But I want to see where they go. There. And there's a jumper to there. Here. Here. Now we're getting down in the area of the PFC. Here, here. And I kind of lose track of them under the paint. So, you know what? I've seen this before. Let me just check something. I may have seen this before. That may be all right. I have seen this happen when a supply has been dropped and the PFC transformer is yanked off the board. That may not be the case this time, but that's when I've seen this before. This exact situation. So, here's our main, one of our main filter caps, the positive side of it. And I'm in continuity. Is that making it all the way down here to this PFC? It'll go basically through the transformer to, is it there? There's the gate. And I think that's probably ground there. That's ground, yeah. So it's not making it there. Oh, I forgot to switch my view. I'm sorry. I do that sometimes. Oh. So, all that following I was doing along, I forgot to switch off of the data sheet. I'm sorry. I do that sometimes. What I was trying to see is, there's your PFC transistor. It should be connected basically to the output, to those filter caps, through the transformer, unless something's open along the way. Unless something's open along the way. And that's what I'm concerned about. This is ground, this is the gate, and this would be the drain of that PFC, I believe. And I'm not getting a connection. Am I looking at this wrong? I don't think so. That's the gate. That's the ground. So this should be connecting to the transformer, basically. Where is that connection? Capacitor. Where is that connection? There's the diode. Where's the connection? What is this? Is that a jumper? It's a jump. Where does it come from? Let me figure this out. Because what I'm suspecting is that their PFC voltage is not making it there. What the heck? I have to refresh my memory on something. Like, where does that come from? Ah, think it's all going. All right, there's a ferrite bead. There's the diode. The drain of that MOSFET should be connected to pin 2 of the PFC coil. There's only really there's 2 pins. There's a third pin if you count the, the shield, the metal shield of it. But it's a coil. One side of the coil is hooked right to those diodes. Let's just go back to overhead a second. If I could. So, here's our coil, our PFC coil. And here is, say, the positive lead of our filter cap in continuity mode. And the 2 legs that I can reach right there, I'm not getting any connectivity. So what am I doing wrong? What am I doing wrong here? Has something been lifted or disconnected? Oh, that's bent right there. This heat sink's bent on the corner. It may be nothing, but it is bent right there. So we have a ground, which is there's a ground pin on this coil for the metal band. There's a copper band around it. That should be connected to ground, and it is. And the other 2 windings on this coil right here should be where our voltage is. The PFC MOSFET should be connected to 1 pin of it. Let's see if it is. It is. So the drain of that MOSFET is connected to one side of this coil. If I go across this coil though, yeah, 0.1 ohms, that's fine. But the other side of it then should end up over here at those filter caps. Unless, yeah, there is a NTC, negative temperature coefficient resistor right here that it goes through. So like I said, if I can show you this pin here of that coil connects to the MOSFET, and the other side of it, of this coil, should be connecting to this NTC resistor. It's looks like a capacitor, but it's a resistor. Negative temperature coefficient. It's connected to that, and I'm guessing it's open. No, it's not open. 2.5 ohms. So the other side of it, though, why does it not land over there? So the NTC seems to be fine. I'll go across these nice leads over here. Yeah, 2.5 ohms. Is there something lifted? Because the other side of it is this big track right here. I feel like I'm overlooking something. Something simple. Something real simple. Because that should connect. It goes there. Goes here. Yeah, that's a capacitor right there. That's not it. This is not, the fuse, that has nothing to do with it. It's here. Oh, this is aggravating. Aggravating. That should go right straight to it. If that is NTC1, and it is, the other side of this, I believe, goes straight to the rectifier diodes. So unless a jumper has been lifted, and there are a lot of jumpers, or a 0 ohm resistor or something. Okay. I've got to go for this haircut, which is why I'm rushing. Yeah, that's 2.5 ohms. Oh, my meter went to sleep. Come back to us, meter. Come back to us. It's 2.5 ohms across that negative temperature coefficient resistor. That's fine. And this is the side hooked to the coil right there. So the other side is what ends up. Oh, there's the diodes right there. So what am I missing here? Here to here. I'm trying to follow these wire jumpers, which is always fun. Because there's the bridge rectifier. What am I missing here? There to there. Yeah, there's the diode right there. Two and a half ohms. Yeah. Coil measure is 0.1. All right, bridge rectifier. Here's the positive end of that bridge rectifier right here. I am wondering if there's an open trace somewhere or something. That. Yeah, I've got to run an errand too, which I may have just stop and start back up. This is driving me insane. This should be simple. I'm just looking at something wrong, I think. It does not look like the PFC MOSFET has been changed. This goes to That's a capacitor. There's something in front of me. Let's see. It's 10 after. All right, I need to go. I hate to leave you with a cliffhanger. We're 2 out of 3. It's not bad. Not bad. But I need to run for an appointment. And maybe we'll try to pick this one back up. If you're interested in it, maybe we can pick this one back up. How long have I been going here? I'm not sure. I lost track of time. But I do want to thank everyone for joining me. And we'll see if we can figure this one out later on. I'll try to avoid working on it. How about that? And we'll pick this one back up. And maybe we'll figure it out. All right. Well, thank you everybody for coming. I do appreciate it. I'll be trying to do some more live streams as time allows. So long for now. And I hope you catch me in the next one.